Bismillahirrahmanirrahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss a few more questions for International A-Level Edexcel M1 Mechanics, and the topic is vectors. We are solving the past paper handout of chapter number 3, Vectors in Mechanics, and I've made earlier videos as well. Okay, you can find the link of the playlist in the description of this video. So first we have question number 9 over here, which is GCE M1 January 2014, question number 2. So the question is saying that a particle P is moving with constant velocity 2I minus 3j meter per second. The requirement of part A is to find the speed of the particle P. Okay, so as simple as that, we need to find the magnitude of this velocity vector, since you know that speed is basically the magnitude of the velocity vector. Here the velocity is constant, so we need to find the constant speed over here. So magnitude of 2I minus 3j, this is supposed to be under root of 2 square plus minus 3 squared. So under root of 4 plus 9, which is under root of 13, and under root of 13 correct to 3 significant figures is 3.61 meter per second. As simple as that. This is supposed to be your answer to part A. Okay. So in part B, it is asking, we have some information over here. The particle P passes through the point A and 4 seconds later passes through the point with position vector I minus 4j. Okay, find the position vector of A. All right. So if I make a sketch for the information what we know so far, okay, as we know that particle is moving with constant velocity 2I minus 3j meter per second. Okay, so horizontally 2 units towards right and 3 units downwards. Okay, so the path of the particle is something like this. All right, 2 units towards the right and 3 units downwards. Okay, so let's say particle passes through the point A at a particular instant, and we need to find the position vector of A. Okay, so let's say particle is at point A somewhere over here, and the path is basically something like this, 2I minus 3j. We are going in the same path. Okay, and let's say we have another point which is B. Okay, and we are talking about the journey from A to B, because 4 seconds later particle passes to the point with the position vector I minus 4j. Okay, so let's say if you start your journey from A, let's suppose at point A t is equal to 0. So we are talking about these 4 seconds. At t is equals to 4, we are basically at the point I minus 4j, meaning we are at the point 1 comma minus 4. Okay, so this is basically what's going on in the question. So we need to find the position vector of point A. So what we need to do, we need to find the position vector of A, and what we are doing, we are considering the journey from A to B. So I'm going to say that R is equals to R naught plus VT, and R naught is basically unknown because we are considering the journey of these 4 seconds. So T is equal to 0 means you are at point A. So R naught is basically the initial position vector of this journey. So therefore R naught is basically the position vector of point A. And 4 seconds later, we are at I minus 4j. Okay. And the constant velocity vector is 2I minus 3j. And the value of t is basically 4. So as simple as that. All right. So what I'm going to do is R naught is equals to I minus 8I, because 2I times 4 is 8. So 8I goes towards the left of the equation. So I minus 8I and minus 4j plus 12j. Okay. because 4 times minus 3j will be minus 12j, and this will come over here. So we are going to simplify the I components and the j component respectively. So r naught is equals to minus 7i plus 8j. This is basically the initial position vector of the particle, and we are considering the journey from A to B. So this essentially means that this is the position vector of point A. Therefore, point A is having a position vector of minus 7i plus 8j meter. Okay, since the velocity is given to you in meter per second, so I've just mentioned minus 7i plus 8j meter with the position vector of point A. So this is supposed to be your answer. Okay, so this was a very brief question. Okay, GCE M1 January 2014, question number 2. So now let's move on to the next question. So the next question is question number 10 of the handout, which is GCE M1 June 2014, question number 5. All right. So let's see what the question says. So a particle P of mass 0.5 kg is moving under the action of a single force 3I minus 2j Newton. The requirement of part A is to show that the magnitude of acceleration of the particle is 2 root 13 meter per second square. Very simple question. So what we are going to do, as we know that we have a single force, we are going to use the Newton's second law of motion, which is force is equals to mass times acceleration. Force is equals to mass times acceleration, and through this, first we are going to find the vector of acceleration in terms of I and j. We are going to find the acceleration vector, and then we are going to show its magnitude. So force is 3I minus 2j, and the mass of the particle should be in kgs, and this is given in kgs. Okay, if this was not given in kgs, you need to convert it into kgs. So mass is 0.5 kg, and the acceleration vector is unknown. Okay, so acceleration vector is equals to the I component is 3 divided by 0.5, and j component is minus 2 divided by zero point 0.5. Okay, so therefore acceleration vector is 6i minus 4j meter per second square. And we need to show the magnitude of acceleration in an exact form. Okay, so the magnitude of acceleration is supposed to be under root of 6 squared plus minus 4 whole squared. So under root of 36 plus 16. So what is the value of 36 plus 16? This is 52. So under root of 52 is basically 2 root 13. So the simplified short form is 2 root 13. So therefore we have shown that the magnitude of acceleration is 2 root 13 meter per second square. As simple as that. All right, so now let's move on to part B. It says that at time t is equal to 0, the velocity of the particle is I plus 3j meter per second. Okay, so this is basically the initial velocity vector. Okay, this is the u vector because it is the velocity at time t is equal to 0. So the requirement of part B is to find the velocity of the particle at time t is equals to 2 seconds. Wonderful. So what we have done, we have found the acceleration vector in terms of I and j in part A. So we are going to use that. Okay. So for part B, I can say that v is equals to u plus at, and we need to find the final velocity vector at time t is equals to 2 seconds, and initial velocity vector is given to us in the question, I plus 3j meter per second. So u is I plus 3j, and acceleration vector we have found in part A, which is 6i minus 4j. Okay, and time is basically 2 seconds. Okay, so v is equals to I plus 12i, okay, and plus 3j minus 8j. So velocity vector is 13i minus 5j. This is the final velocity vector when t is equals to 2 seconds, meter per second. final velocity vector when t is equals to 2 seconds. 13I minus 5j meter per second. All right, so this was the requirement of part B. Now we have another particle, and for that purpose, I'll bring the picture of the question on the next page. Okay, so we have another particle q which moves with constant velocity v, which is 2I minus j meter per second. The requirement of part C is to find the distance moved by this particle q in 2 seconds. So, as simple as that, particle q is moving with constant velocity throughout the journey. Okay, so what's happening is that we need to find the distance. So, first of all, I'm going to find the displacement vector. Okay, and after finding the displacement vector, I'm just going to find the magnitude so that I would be able to get the distance. Okay, so particle q is moving like this with a constant velocity of 2I minus j. So since the velocity is constant, so displacement is v times t, because when we multiply velocity with time, we get displacement vector. So first of all, I'm going to get the displacement vector for particle q, which is supposed to be 2I minus j multiplied by t. The value of t will be 2 seconds. Okay, so the displacement vector is 4I minus 2j meter. Okay, and now I'm going to find the magnitude of this displacement. This will give me the distance. Okay, magnitude of the velocity is the speed and magnitude of the displacement is the distance. So magnitude of this vector will be under root of 4 squared plus minus 2 whole squared, meaning under root of 16 plus 4. So this is under root of 20, and under root of 20 correct to three significant figures is 4.47 meter. This is supposed to be your answer. All right. So now let's move on to part D. So in part D, it says that show that at time t is equals to 3.5 seconds, both particles are moving in the same direction. So basically, we need to show that at a particular instant t is equals to 3.5 seconds, particle p and particle q are moving in the same direction, meaning their velocities are scalar multiples of each other. Makes sense? Because you know what's happening is that particle q is moving like this with a constant velocity of 2I minus j meter per second. Let's say something like this, 2I minus j. Particle q is moving with constant velocity throughout. However, particle p has constant acceleration, which means that particle p's velocity is changing every time. With every value of t, the velocity of particle p is changing. Okay, so at t is equals to 3.5 seconds, we would need to identify what is the velocity vector of particle p. Okay, because particle q is having the same constant velocity throughout its journey. So basically, the idea behind this is that, which I've discussed in my earlier videos as well, velocity vector tells you the direction of motion of the particle. Velocity tells you the direction of motion, where the particle is actually moving. Okay, so this is basically the whole idea behind this. Because when we were considering particle P, so the initial velocity was I plus 3j. Okay, I plus 3j, something like this. And obviously, with the value of t being changing throughout, the velocity of particle p will change. So the velocity vector will change. Okay, this is basically the whole idea. So at t is equal to 3.5, we need to just identify the velocity vectors of particle p and particle q. So if I consider particle p first, since particle p is having constant acceleration, meaning the velocity is variable, so v is equals to u plus at, and at t is equals to 3.5, I need to find the final velocity vector of particle p. So the initial velocity vector of particle p was I plus 3j. Okay, I plus 3j. And the constant acceleration of particle p we found in earlier part A, 6I minus 4j. Okay, 6I minus 4j is the constant acceleration vector of particle P, and time is basically 3.5 seconds. So just find this final velocity vector. So I'm going to say that V is equals to I plus 3.5 times 6 is 21. So 21I, and then plus 3j minus 4 times 3.5 is basically 14. So minus 14j. So the final velocity vector is 22I minus 11j meter per second. This is the final velocity vector of particle P at the instant t is equals to 3.5 seconds. Okay, and now as far as the particle Q is concerned, so it is having a constant velocity of 2I minus j meter per second throughout the journey. So we just need to establish that these two vectors are scalar multiples of each other. Okay, because when one vector is a scalar multiple of another vector, this means that they are parallel to each other, and this also means that one vector is moving in the same direction as the other vector. Okay, so this is basically the whole idea behind this. Okay, both vectors are moving in the same path, so they should be scalar multiples of each other. So I can say that the velocity vector for particle P is like this, that velocity is equals to taking 11 as common, taking 11 as common, multiply by 2I minus j meter per second. This makes sense. Okay, the velocity vector of particle P is 22I minus 11j, which is exactly the same thing as saying taking 11 as common multiplied by 2I, taking 11 as common multiplied by 2I minus j. Okay, so at t is equals to 3.5, what we have established, the fact that at t is equals to 3.5, the velocity vector of particle P is 11 times the velocity vector of particle Q. Okay, so both particles are moving in the same direction. Therefore, both particles, both particles are moving in the same direction. Okay, so this is how you attempt this part D. All right, you need to be well aware, you need to be well versed with all of the basic concepts before attempting the past paper questions. Okay, but I try my best to give detailed explanation as much as I can. So basically, when one vector is a scalar multiple of another vector, we also say that the vector is parallel to another vector, and we also say that both vectors are moving in the same direction. So basically, particle Q is moving with constant velocity throughout 2I minus j, horizontally 2 units towards left. This is basically the path of motion for particle Q. And at the same instant, at t is equals to 3.5, particle P is moving like this, 2I minus 11j. So these both particles are moving in the same direction at t is equals to 3.5. Particle Q is throughout moving with constant velocity 2I minus j. Okay, and particle P is basically only at t is equal to 3.5, it is a scalar multiple of this 2I minus j vector. So this is basically the whole idea behind this. Okay, so this was basically question number 10, question number 10 of the handout, which is GCE M1 June 2014, question number 5. So for the sake of this video, I have discussed this question number 10 of the handout, and the previous one was question number 9. Question number 9, which was GCE M1 January 2014, question number 2. All right, so I'll see you in my next video. Stay tuned to my channel. Thanks for watching. Assalamu alaikum.